Hello, this is proton science. Now, I want to prove the formula for calculating the work done in an elastic material. Now, suppose we have a spring here, and then in this spring here, there is no load in it. So, since there is no load in the spring here, it means that we can have a force here called F1, and the force or the weight on this spring is equal to 0. Now, that means there is no extension in this case. Now, when this same spring is loaded, when it is loaded with this load here, it is going to cause an extension E. So this is its original length from here. This is the original length, and this to this point shows that there is an extension. What caused the extension? It is definitely the force, which we are going to call F2. Yes. So in this case now, we now say that the average force exerted on the spring is going to be equal to F1 plus F2 all over 2. Now, looking at it carefully, we discover that in the first case, where there was no load or force on the spring, we say that the F or the force is 0 Newton. Here, F2 is not 0. Why? Because it has caused an extension in the spring. So in that case now, the average force is equal to 0 plus F2 all over 2, giving rise to average force equal to F2 all over 2. So in this case now, since F2 is the only force exerted on the spring or put into the spring, we are going to call this F2 here F. So in that case, this becomes the average force. So in that case now, the average force is going to be F over 2. Yes, meaning that F2 happens to be the only force exerted on the spring. At F1 there was no force on it, so F1 is 0 Newton. So having this at the back of our mind now, how can we now get the formula for the work done? Now, this is what we simply do. We are going to recall that the work done is equal to force times distance. Yes, work done is equal to force times distance. Yes, in that case now, the work done or the energy stored in the spring is now going to be the average force times the extension. So the average force times the extension in the spring. So in this case now, the work done is going to be the average force, which we have here as what? F over 2 times the extension, giving rise to W equal to Fe over 2, which we can express here as W equal to 1 over 2 Fe. Yes, this is the formula for the work done in an elastic material. But then, can we get another formula? Yes. How? We are going to apply Hooke's law here in order to find the other formulas. So in this case now, we are now going to say according to Hooke's law, F is equal to KE. Yes, according to Hooke's law, F is equal to KE. In that case now, since in this formula here we have that W is half FE, so in that case, in place of this F here, we are going to have what? KE into this formula. So in that, we are going to say, let's call this equation 1. We now say, okay, put F is equal to KE into equation 1. So when we do so, we are going to have here that W is equal to, since the first formula W is equal to FE, now W will be equal to 1 over 2. Yes, W equal to 1 over 2 FE. So W is going to be equal to 1 over 2 times F is now KE. So we have KE times the E that was already there. W is now equal to half KE squared. This is another formula for calculating the work done in an elastic material. There is still another one. Now, so in that case, we are still going to apply Hooke's law. So Hooke's law is still telling us that F is equal to KE. That's still Hooke's law. But in this case now, we are going to make K the subject of the formula. Now, if we make K the subject, or maybe, okay, let's start with this other one. We make E the subject in this particular case here. To make E the subject, E will be equal to F over K. Yes, E will be equal to F over K. So I'm now going to put E equal to F over K into the equation 1. Yes. So in that case, wherever I find E in this equation 1, I'm going to put F over K. Let's see how it goes. So in that case, equation 1 says that W is equal to half FE. Yes, half FE. So in that case, we are going to have W is equal to half F times E is now what? F over K. Meaning that W is now going to be equal to half F squared over K, which we can still express it this way. So we can have this as equation 3. So that's our third formula for work done. Do we still have another one? Yes. Now, in this other one here, we are going to make K the subject. But then, where are we putting the K? Because if you look at this first formula, it doesn't have K. So, in that case, if we make K the subject, we can put it into this other one here, and then we derive the next equation. But for now, this is where we are going to stop. But then the next equation is still valid for us. You can still use that next equation and we work out the formula for work done. But these three are the three main formula for calculating work done in an elastic material. This is the first one is first half FE, that is W equal to half FE, W equal to half KE squared, and W equal to half F squared over K. So remember I said that there is another formula. What is the formula? It is just W equal to what? F times S, which is the formula for work done. So the formula for these are the formula for calculating the work done in an elastic material. Yes, the work done in an elastic material, or energy stored in an elastic material. So my name again is Proton for Science. This is my channel. Like, subscribe, share, so that I can send more videos. Thank you.